So now that we've spent some time talking about the basic idea of a stack, of a collection, as well as some of the basic techniques that we use to actually implement these things in Java, let's take a look at an application. So what we're going to look at is evaluating a postfix expression. This will be a rather nice and concise example of the power of a stack. Before we actually jump into the source code though, we're going to spend a little bit of time talking about how this thing works, and then I'll go ahead and jump to BlueJ. So postfix expressions. You may or may not have heard the term before. Something you may have heard before, though, is infix notation, which is the notation we use every day to write mathematical formulas. So there's the example here, right? 15 minus 8. This is the normal way we would write an expression, right? We'd put our operand in the front, operator in the middle, and then an operand at the back. Infix notation, the operator occurs in the middle. So this is the way we typically write math. Unfortunately, it can be a little bit tricky sometimes. We have to use things like parentheses to make sure things are evaluated in a certain order. Otherwise, we have to know and follow the normal order of operation. They can be a little bit tricky. So one of the alternatives that people came up with is something called postfix notation. So over here in the middle of the screen, this is an example of postfix notation. This is a postfix expression that does exactly the same thing as the one on the bottom here. It takes 15 and it subtracts 8 from it. The difference being that that operator, right, that minus, that thing is after the two operands that go to it, right? It's after the 15 and the 8. It's not in between them. What we're going to be talking about in this section is how to read in a postfix expression and then use a stack to actually figure out what its value is, right, to evaluate it. Let's go ahead and take a look at a more complicated expression. So over here we have another usual infix expression, right? This is what we'd be used to writing. And over here, right, notice we've had to put in all these parentheses to make sure things evaluate like we want them to, right? Normally we have order of operation rules for something like minus and plus, and those may conflict, and so we need to put in parentheses to make sure things happen in the correct order. This is a little problematic. One of the benefits to postfix expressions is that we eliminate that, right? It's no longer unclear what operators are associated with what operands. Instead, we just have a rule that says, the operands are the two things to the left of where you see an operator, right? It's just one rule for whatever you happen to be doing, right? Addition, subtraction, it's all the same. Looking down here, what we did is we rewrote that first expression in post order. And what you may notice is that the parentheses are now gone, right? We don't need those anymore because we have kind of a more firm rule, right, that tells us what operands should go to what operators. And this is pretty nice. Although it may be harder for us to read the expression because we're used to infix, this is something that we can parse and figure out what its value is without any issues of ambiguity, right? We always know what it's going to evaluate to. We don't have to worry about things getting messed up because we've forgotten to put it in our parentheses. So the problem we want to tackle in this section is actually take the infix expression and then writing an algorithm that uses a stack in order to evaluate it and find out what number it results in. So on this next slide, we have the basic outline of how we'll do that. So picture you have some postfix expression, right? Like the one we had on the previous page. Just picture 3, 4 times 2, 5 plus, right? Something in this general form, right? Something that looks like a postfix expression. Imagine you have one. How do we evaluate it? Here's the basic idea. Imagine you have that expression as a string. Start looking at it from left to right and look at it one part at a time, right? One number or one operator at a time. Whenever you see an operand, push it onto a stack, right? Save it for later usage, right? We need to wait and see if there's some sort of operator that's going to involve that operand. When you see an operator instead, right, as you scan that expression, then you'll pop the first two elements from the stack, right, the last two things that are put on there, perform the operation on those two, right? So you'd pop off the last two things, and maybe you do then an addition, a multiplication, whatever the operator is you happen to see. And then you'll have some result. And that result, put it back on the stack. This general process will be repeated until you've walked through, right? You've scanned that entire expression. You're just going to go bit by bit with the actual numbers, right? Either we've read the numbers directly or we've computed them as an operator. Those will accumulate over on the stack. The stack will kind of work as a holding area for the numbers that are computed while trying to figure out an entire expression. At the end, once we've read through the entire expression, then the last file that's on that stack, and there should hopefully be only one thing there, will be the final value that we've computed from parsing the whole thing. I know this may be a little bit difficult to understand with just the text, so let's take a look at the diagram that they provide. And then in a minute, we'll go to actually the program itself and walk through how that thing works in practice. So here's a diagram that's showing us parsing this infix expression, right? So this is our thing here we're going to parse. So like we said, the main part of this algorithm, right, is going to be look at each of these in sequence, right, and then act on them based on whether it's a number or it's an operator. So over here, right, imagine you have to start at 7. And initially, right, maybe you have an empty stack, right? There's nothing there. Well, what our algorithm will do is it's going to scan from left to right. First, it's going to see that 7. Well, that 7's a number, so via our algorithm from the previous slide, we're going to push it onto the stack, right? So we're going to add it right here. So it ends up being something like a 7 here. And then you continue, right? Scanning again, you see a 4. 4 is something we would add on the stack. Got to scan again. This time we see a -3. -3 goes on the stack. And that gets us to this picture here, right? Now we're on the first part of this diagram here. And now something different happens. If we continue to scan, we're going to see the time symbol. Well, if I see a time symbol, I'm not going to push on the stack. Instead, what I'll do is I'll pop the last two things I put on there, right? So this thing will get popped, and this thing will get popped, right? The -3 and the 4. So those are the last two numbers I've seen. And then I'll apply that multiplication symbol, right, that times operation to those two values, right? So I'll do 4 times -3, which gets me -12. And then that -12, I'm going to push that result on the stack, right? So that leaves me out here, right? I still have the 7, which is the very first thing I read in, and then I have the -12, which was the result of me doing the multiplication operation. Moving forward, I'm going to keep on doing the same thing. So next, I'm going to see a 1. That means I just want to put a 1 on the stack. Next, I see a 5. That means I'll put a 5 on the stack. Then I see my second operator, which is going to be an addition now. So this addition, we're going to process it the same way. We're going to take the top two things, pop them off, and apply the operation, right? So in that case, I'm going to add 5 and 1, and I get 6. That 6 will then be pushed onto the stack, getting me over here. Again, that came from our 5 and our 1 being removed. Then, right, once we've finished processing that plus, we'll move along and go for the division. Again, that works by us popping off the last two elements. So we end up with 6 divided by -12, which gives us our -2. Then that -2 is going to be pushed on the stack, right? So then we'll have our -2 and then our 7, which has still been there. Again, it was the very first thing we read in. It's kind of just stayed there because we haven't had any operators that have needed to go down that deep into our stack to process something. The last thing in this expression is another multiplication. So we'll continue scanning along. We see that multiplication. And then we'll take out our -2 and our 14. At that point, we can do our multiplication, and we get back our -14. And that -14, that's going to go back on the stack, right? So these two things have been taken out, and then that final value is going to be put on here. And so as you can imagine, that stack now has the final result of this expression. And so if you want to get it back out, right, if you want to see what the result is, all you do is pop from the stack, right? And that last value that's in there is the final thing that was computed, right? The result for the overall expression.